So today we discuss dividing polynomials. In our first example, we have a trinomial divided by a monomial. So what I'm going to do is rewrite this as 2y squared minus 3y minus 9 over 3y. Now, this problem's in some sense already done because I've done the division. I have one fraction left. However, in this section of the book, they're going to ask us to split this apart into three separate divisions. They're going to ask us to take 2y squared over 3y minus 3y over 3y and 9 over 3y. In each of these cases, these divisions all simplify. I have y squared over y, which is 2y over 3, 3y over 3y, which is 1, and 9 over 3, which is 3 over, and then I have the y left on the bottom. So at this point, this is the intent of the solution when they ask us to divide a polynomial by a monomial. Again, at some point in our algebra careers, this is going to be the acceptable answer because it's a simplified fraction.
In this case, we're dividing a trinomial by a binomial and trying to reduce it if we can. Splitting this up into three different fractions clearly won't help because we'll have a 2r squared over an r plus 3, and nothing's going to reduce since we have an addition on the bottom. So the next thing to try is to see if we can take and look at it in a different way, like so, and find out if r plus 3 goes into this, but we'd have to see if r plus 3 is a factor, which then brings about, can we factor the numerator? Let's try it. I have a 2r and an r because that's the only way to get a 2. And then I need a 3. There's only one way to get that, and I need a 5. So I'm going to put my 3 here, which will get me a 6, and a 1 here, which gets me a 1, and 6 and 1 get me a 5. So that's a plus and a minus. Positive 6, negative 1 is positive 5. And what do you know? The r plus 3 on the bottom will reduce. So that division is just 2r minus 1. And again, that's only going to work because the trinomial on top factors into a term that's on the bottom. It's not always going to happen.
Now we're going to go back to fourth grade for a little bit and do some long division. And you remember when I had a number divided into another number using long division, I block off the first two numbers, say, does 13 go into 40? Sure, goes in 3 times. I multiply the 3 times the 13, get 39, and then subtract, leaving me with 1. I would bring down the remaining numbers and then say, does 13 go into 12? No, so what I must do is have a placeholder. And then does 13 go into 123? And of course the answer is yes. Goes in a total of 9 times. And 9 times 13 is 117. Subtract the 2. And you'll notice I have a total of 6 left. Bring down the 4. 13 goes into 4 how many times? Or I'm sorry, 13 goes into 64 how many times? And that's going to be 4. Multiply, I get 52. We end up with a remainder of 12. And we could put a remainder 12 here. Also, what could happen is we could say, well, this is basically 3,094 and 12/13ths left over. Now we're going to do this with polynomials. We're going to take x squared plus 7x minus 15 and divide into it x minus 2 using long division. Now the way I do this is similar to the fourth grade method, although all I'm going to use is my first term here in order to see how it divides into this polynomial over here. I say x times what is x squared? It's simply x. Now I distribute the x to the number out in front, giving me x squared minus 2x. Our next step, just like in 4th grade, is to take and subtract. So when I subtract, I distribute the negative through. So this term becomes a negative, this term becomes a positive, and then I add. So this goes to 0. This is 9x minus 15. Again, I say x times what is 9x? That ends up being 9. I multiply, I get 9x minus 18. Once again, I'm going to want to subtract this quantity. So I distribute the negative through, giving me a negative here and a positive here. Then I add. Left with 0 here and 3 here. So my solution is x plus 9 with a remainder of 3. Another way to express that is x plus 9 and 3x minus 2 left over. So now we'll do a little application. We have a rectangle with an area of 3x plus 90. So I'm just going to write 3x plus 90 on the inside. And its length is x minus 3. We want to find the width. We know the area is equal to the length times the width. So what I'm going to do in order to find my width is divide by the length. And we'll do this using long division. So let's say I have 3x plus 90. And I'm going to divide x minus 3 into that. I say what multiplied by x is equal to 3x, and that's simply 3. And what I'll have next is I'll multiply, get 3x minus 9, and I'm going to subtract that, which means I distribute the negative through, and then add. This goes away, and I'm left with 99. So I'm left with 3 and 99 over x minus 3 value. Notice it doesn't make a ton of sense because what I've got is a situation where it doesn't go in necessarily evenly. So in the real world case, you would have something like a fraction for my width. Let's go through and do another long division. This will bring up a little bit more of a challenge. You'll see in this case, and one of the things to notice before you even write the problem out, is take a look at your polynomial. And this polynomial goes from a cubed to an x to the first term. If we go back to our 4th grade example, we notice that this went from a 10,000, and notice we had 0 in the thousands place, but only 2 in the hundreds place. Right? This 0 acted like a placeholder. Now in the example that we're talking about now, we need a placeholder for our x squared term. So what I really have is x squared, or x cubed, minus 0x squared minus 34x plus 45. And that's all divided by x minus 5. So when I set this problem up, I'm going to write x cubed minus 0x squared minus 34x plus 45. Now divide that by x minus 5. And work this problem out with my placeholder in the problem. Very important step. So I say what multiplied by x is x cubed, that's x squared. Distribute, get x cubed minus 5x squared. Notice the importance of the placeholder because now we're going to need to take and subtract. Again, distribute the negative through and add. X cubes fall off. I have 5x squared minus 34x plus 45. X times what is 5x squared? That's a 5x. Multiply, we get 5x squared minus 25x. Again, we'll have to take and subtract. Distribute the negative through and add. That's 0. Get a total of negative 9x plus 45. What multiplied by x is negative 9x. That's a negative 9. Distribute. I get negative 9x plus 45. And once again, I take and distribute a negative and subtract. This goes to positive, negative, and I'll add. And I get 0. Now, this brings a remainder of 0. Whenever there's a remainder of 0, we can say that x minus 5 is a factor of x cubed minus 34x plus 45. And once again, whenever your remainder is 0, that term is said to be a factor of the other term. That's all we've got for you. Make sure you're up on your long division, fill out your lesson summary, and we'll talk to you tomorrow.